This is a carburetor, and this is a special 3D printed see-through carburetor, and this is a high-speed camera with a macro lens on it. You see where this is going. If you've ever cranked some type of lawn care product with a small engine on it, you have interacted at some point with a carburetor. The question is, what does this little device do? Yes, it mixes air and fuel together, but how? Like, I want to understand how it works. As a mechanical engineer, I thought I had an understanding of carburetors until the day I went to visit my dad, who was replacing a carburetor on his tiller. My dad is a really good teacher, and he has a really good understanding of how mechanical things work. So I decided to suspend everything I thought I knew about carburetors and just ask him to teach me from the ground up.
Teach me.
What followed was a 45-minute lesson on everything about carburetors.
That's the main jet of the carburetor. See the holes on the side? Bowl. You got gasoline in there. Float. See the needle going up and down right there?
Yes, sir.
Yes, that's the throttle right there. You can see that. Choke. You're running open right there. The suction, the intake. When the cylinder goes down,
It's a vacuum.
It sucks air through here, your finger right there. The vacuum will pull this open. The valve closes in the cylinder. Your compression stroke comes up, compresses the gasoline. Your spark plug fires, pushes it back down.
So my dad gave me a master class in how carburetors work. What I'm going to do is try to explain in brief detail what he taught me, and then we'll move on to the see-through carburetor where I think you can understand it a little bit better. So at this point it's clear we're going to have to make our own see-through carburetor. And remember, there's two components of the carburetor, right? Okay, first let's talk about the venturi. If you are like me and you have really old books on your shelf, you might have one that explains carburetors in great detail and explains that a venturi is a really cool thing where you take fluid that's flowing through a pipe. If you neck it down at some point to a smaller cross-sectional area, the static pressure at that point at the throat decreases, creating kind of like a vacuum in that one spot. Well, that can be used to suck fuel up into the venturi. All right, so let's look at that. So the venturi part of the carburetor is for sucking the fuel up into the line. The second part of the carburetor, the bowl, is for holding the fuel. So after a lot of collaboration, conversations, and actual engineering meetings, we came up with a 3D printed solution for a see-through carburetor. It consists of a laser 3D printed housing, which incorporates both the venturi and the bowl, and we removed a float and needle from a thermoplastic carburetor made by Briggs & Stratton. We laser cut a front cover that would allow you to see the entire thing, and then we 3D printed a choke and throttle lever out of PLA plastic. So this is the 3D printed see-through carburetor. And let's assume the engine is out here to the right. It's taking advantage of the fact that the intake stroke has a vacuum and it makes air want to flow this way into the engine. So once air starts flowing this way, what happens is air comes in this side and it starts necking down into the venturi there. Like we said in our book earlier, where flow is high, pressure's low. And so if you have gasoline down here in the bowl, down here, all full up right here, what you do is you have a little bitty pipe right here, like a straw, that goes up and goes into the center of the venturi. And what that does is that creates a little bitty jet of liquid that comes up right here because of that vacuum. And then once that happens, it mixes and then it goes downstream into the engine like this. So basically you have nothing but air on this side, you've got the fuel coming up here, and then you have a mixture that goes from here forward. That's basically what a carburetor does. The choke and the throttle up top, that's the flappy things we were showing earlier. That's the choke and that's the throttle. Basically what they do is control the mixture that goes to the engine. If you close off the choke and you restrict the amount of air that goes down into the venturi, then you can create what's called a rich mixture, meaning the mixture that goes to the engine is rich in gasoline. You might want to do that if you're starting the engine and it's having a hard time firing up. If you want to lean the mixture like this, that means the mixture downstream is lean of gasoline. And there are different reasons to do different things, but if you have an ideal mixed choke right here and you have full throttle, then you're gonna have great chemistry downstream and it's gonna make the engine run really, really fast. So these are the two controls that most carburetors have, and this is basically the simplest design for a carburetor that can exist. Fuel flows in here, and when the float starts to float, it moves this needle which presses into the seat and stops the flow of fuel into the bowl, so you always have the right amount. Oh, it's running! Okay, I triggered. We can kill it. Kill it, yeah.
You can see air-fuel mixture going in the combustion chamber.
This is intake.
No,
fire
intake
is when it's sucking in.
Right.
Intake.
Yeah.
Fire.
Intake valve closes. Fire.
Exhaust stroke.
Yes.
Another intake.
Right.
You can see the vortex behind the throttle. Do you see that?
You can. Oh, it is. It is. Turbulent flow is a vortices turbulence.
Yeah, absolutely. Almost kill it.
That's a good carburetor.
So the fuel is coming up into the jet. That's the main jet, right?
Where's that entering? Right there?
Yes, it's coming straight up in the middle of Venturi, and then the intake blows
air
across it. Look at all the stuff dancing down there. Let's run it again and just look at the top of the fuel in the bowl. I just want to see what that looks like. The mechanical oscillations are way more violent than I expected.
Well, the engine's running pretty fast right there. Each time you see a shake is a stroke, isn't it?
No, I don't think so.
You don't?
I think it's a vibration mode. I think it's a harmonic.
You think it's a tuning fork?
I do. Okay, so now we understand the carburetor on a macro level. We have built a functioning carburetor, which is awesome. But now what we need to do is, I want to see the tight stuff. Like, what happens when that jet of fuel comes up and the air intake comes over the top of it? What does that look like? All right. Got it.
Ooh.
Yeah, I know.
Oh. That was it's suspended. That drop of fuel is suspended in the air, and then the suction comes and breaks it all up. Derek is going to love that.
Because of turbulence?
Yes. That's changing a laminar coming in here too, turbulent. Ooh.
Converging, diverging nozzle. So a carburetor is just a rocket nozzle. It's a rocket nozzle, that's what it is. I mean, you're speeding up.
Watch it. Oh.
It's a little drop and...
Yep. Carburetor tries to do is increase the surface area on a molecular level, right?
What do you mean?
In order to get full and complete combustion, you need all the surface area that you can get of the fuel.
Because ideally you'd have an oxygen molecule right next to a fuel molecule.
Mm-hmm.
For the next shot, we wanted to see if we could shoot the high speed down the throat of the Venturi. So Trent jumped in to help because we needed more hands. Just pop the choke out and then we're just going to look straight down the barrel.
I think you need to block about 3/4 or at least half of it. Yeah.
All right, so that's gonna lean our mixture, right?
Yep.
Are you pulling focus?
I'm gonna have to once it's running.
Yeah. Oh! I just hit your mic. It flattens the dropout.
It does. It does.
It flattens the dropout and it distributes it. Look at it! I now have a three-dimensional understanding of how a carburetor intake air interacts with the fuel coming up in the main jet.
That was worth it.
This journey started by simply asking my dad how carburetors work. And by taking the time to build and operate one by hand, we learned that the design of a carburetor is simple, yet very complex. And the fluid dynamics at play are downright beautiful.